Hello everyone, my name is Yin-Cong and I'm here to talk about my paper, Gaussian Processes on Graphs via Spectral Kernel Learning. So learning on graphs has become increasingly popular over the last few years. In particular for us, kernel functions have been derived on graphs and they provide a measure of similarity between nodes. Now with classic kernel functions, it's known that they have a positive spectral function. And this function can be obtained by taking the Fourier transform of the kernel. What's interesting about these is that this spectral function can be learned, and there has been work that's gone into learning this spectral function as a way to learn the optimal kernel. What we aim to do is something similar. We want to learn the spectral function of these kernels defined on graphs. The difference is these are defined on a discrete domain, so any previous methods don't translate trivially. We then apply this with a multi-output Gaussian process for graph signal predictions, where graph signals are vectorial predictions where each outcome falls on a graph. So how do we do this? Well, we model the kernel spectral function with a flexible polynomial, and then we learn the shape of this polynomial through a maximum likelihood approach with the Gaussian process. We also do this with an algorithm that we propose so that the learning happens in a constrained manner and that we get a positive spectral function. This also establishes a connection with filtering in graph signal processing. These are some of the things that are discussed in the paper. What this means is that we get a model that is able to adapt to the spectral properties of the data for a better performance. So if you would like to discuss this more in detail, please do drop by so that we can talk about it in person.